welcome to the fourth tutorial in the series on trigonometry. And in this tutorial I will be talking about a very important and useful rule called the sine rule. And this is a very powerful rule that enables you to calculate unknown sides and or angles in arbitrary triangles. Let's derive it rather than just state it. Let's see, because it's actually very easy to derive. Let's see where it comes from. So let me just draw any old triangle. So it's not a special triangle, it's just any old triangle. And let me label it A, B, C for the vertices, and then little a, little b, little c for the sides. And for our purposes it's very helpful to just bring down a perpendicular, and let's call that the height of the triangle h. It's perpendicular to the base, so the right angle there. And you see we have, this should have been b here. We see we have two different right angle triangles, and so we can immediately use our definitions of sine to great effect here. So let's look at angle A. By definition, the sine of the angle in a right angle triangle is the opposite, which in this case is h, divided by the hypotenuse. And the way I've labelled it here, the hypotenuse is b. Now in the triangle on the other side, I can talk about the sine of b. It's going to be the opposite to the angle, which in this right angle triangle is h again, and then divided by the hypotenuse of this right angle triangle is the side a. So these relationships just follow from the definitions of sine. In this relationship, let me multiply by b, and that will then give me just h on the right hand side. So I have that b sine a is equal to h. And then in this relationship, let me multiply by a, and likewise that just leaves h on the right hand side. And you see now I have two relationships, each involving h, or each giving me h, but in terms of two different quantities, and therefore these two quantities must be equal to each other. So it must be the case that b sine a is equal to a sine b. And so a way this is often written is to divide the sines into the denominator. So if I divide by the sine of b and by the sine of a, this will come downstairs, and this will come downstairs over here, and I have this relationship. b divided by sine b is equal to a divided by sine a. If you find this kind of manipulation a bit awkward in terms of taking things across the equal sign, don't worry. I will do a special tutorial on rearranging equations, because I notice it's a topic that many students have difficulty with, and so we'll go over the various rules for manipulating equations. But if you did find this awkward, take it from me that these manipulations are fine, and we have b over sine b equals a over sine a. Now there's nothing special about a and b compared to c, because this is just a common or garden triangle. I could have taken down a perpendicular in for a different length, and so in fact this is also true for little c over sine c. And we have the statement of the sine rule then that a over sine a is equal to b over sine b, and these equal quantities are also equal to little c over sine of angle c. And that's the sine rule. It's very powerful. What it says is that if you know an angle and its opposing side, then this ratio of the side divided by the sine of that angle is a constant for all other pairs in the triangle. So if you know anything else about the triangle, you can quickly work out angles and sides. And let's just do a few examples to see how this works. So let me just draw a triangle here. Let me imagine that this angle here is, let's say, 40 degrees. And let's say I know the opposing side. Let's say it's 5 units. Let's say I know this angle. Let's say that angle is 50 degrees. We can immediately determine this side over here. Let's call that side B, because 5 divided by the sine of the opposing angle must be equal to this unknown side divided by the sine of its opposing angle. You see, we always work with these pairs of an angle and its opposing side. So this side divided by the sine of its opposing angle is equal to this side, which is unknown, divided by the sine of its opposing angle. And so if I multiply by the sine of 50, then I have that 5 over the sine of 40 degrees times the sine of 50 degrees is equal to the thing that I do not know, the unknown side B. And let me just get the trusty steam-powered calculator from the Victorian times. Here it is. And calculate this. So I have the sine of 50 degrees divided by the sine of 40 degrees and then multiplied by 5. And that gives me 5.958 ... And again, I think for these sorts of problems it's good to give maybe 2 decimal places, so let's just round up here. It's good practice for rounding, so the next digit after 5 is bigger than 4, so we round up and we have that B is 5.96 units to 2 decimal places. Okay, let's do another example. I'm just making these up on the fly, so if the diagrams are not very good, I do apologize. Let's say this angle is 35 degrees. Let's say this side is 7. Let's say this side is 6. And then we want to know this angle, which is currently unknown. Let's call that angle B. So again, the key point here is that we have an angle and its opposing side. So the ratio 7 divided by the sine of 35 degrees gives us a constant for the triangle, and all other ratios, this length divided by the sine of this angle, or this length divided by the sine of that angle, will equal this ratio. So 7 over sine of 35 will equal this length divided by the sine of its opposing angle, which is the thing that we do not know. Now we have to do a little bit of rearranging of this equation to sort of get the unknown angle into prime position. So what I suggest is that we multiply by sine of B. So we have sine of B times 7 over sine of 35 degrees is equal to 6. For the sake of this, I think let's just work out what 7 over sine of 35 is. So 7 divided by the sine of 35 is 12.204. So we have 12.204 times the sine of B is equal to 6. So the sine of B then will be 6 divided by that number. So I'm just going to do a little trick here. I'm going to take the inverse of this, if I can find it on my calculator, there it is, and then times it by 6. And we get 0.49 ... Now, if you know the sine of an angle and you want to know the angle, you're going to use something called the inverse sine, which is written like this, and it gives you the angle whose sine is the number that you have, okay? And it will be on your calculator, you can see it's there, inverse sine. So I just press inverse sine and it gives me the angle, which is in this case 29.4 degrees. For angles, I don't know, maybe it's not consistent, but I probably tend to just give one decimal place for the angles, given that we already have two significant figures before the decimal place. So those are two examples of using the sine rule. They're pretty typical examples. You're always going to have an angle and its opposing side given to you if you're expected to use the sine rule. Otherwise, actually, you can't use it. That enables you to get a ratio which you can then use to find other lengths and sides. Either you'll be given another angle and you can find the opposing length, or you'll be given another side and you can find the opposing angle, as we've shown here. So that's the sine rule. Easy to understand where it comes from and fairly straightforward to use with some practice. So I hope you found that helpful, and I'll see you in the next tutorial where we're going to look at the slightly more awkward cosine rule. I'll see you then.